Hi, this is Mr. Warden. This is the video key for Geometry Do Now 31.1. And so I'm introducing the concept of special right triangles. So this is a 30, 60, 90 right triangle, which means it's half of an equilateral triangle. We have the short leg, which is 1, and the hypotenuse, which is 2. And we want to find out what the long leg is. Okay, so these two, so this side has to be C in the a squared plus b squared equals c squared. The hypotenuse is going to be opposite the right angle. So we would call this side this angle C and this side little c. And it doesn't matter which one of these gets A or B. I'm going to call this angle A, which makes this a side lowercase a. I'm going to call this angle B, so the opposite side will be lowercase b. So what we need to do is figure out what B is. So there's the a squared plus b squared equals c squared formula, but we can rearrange that into c squared minus a squared equals b squared. So that means that we're going to have 2 squared minus 1 squared equals b squared. Okay, then that's going to be 4 minus 1, and that's going to equal 3. Okay, so b squared equals 3. So to find out what b is, we get the square root of b squared and the square root of 3, and we'll end up with plus or minus the square root of 3. We're going to discard the negative since we're measuring things and geometry, so we're going to use the positive square root of 3. And that's always going to be the relationship of sides on a 30, 60, 90 right triangle. The short side is going to be half the hypotenuse, and the long leg is going to be the short side times the square root of 3. That one is 1 times the square root of 3. Here we have another 30, 60, 90 right triangle. We know this is 60 because that's 90. 90 plus 30 is 120, plus another 60 gets 180. And so C is definitely going to be twice 5. So C equals 2 times 5, which will be 10 units. And B is going to be square root of 3 times 5. So that'll be 5 square root of 3. So this side will always be the square root of 3 times this side, this short leg, and the hypotenuse will always be twice the short leg. So that is the relationship of sides with a 30, 60, 90 right triangle. But this is half of a square sliced diagonally. We got a 45, 45, 90 degree angle. These two sides are the same, and these are the legs. This is the a squared and the b squared. So we can say a squared plus b squared equals this side squared. That'll be c squared. So I'm going to say instead of a squared plus b squared, it's just going to be 1 squared plus 1 squared equals c squared. And that means we've got 1 plus 1 equals c squared, which is 2 equals c squared, which we can get the square root of both sides. So c will equal the square root of 2. So the relationship of sides on this is always going to be a 1-to-1 to square root of 2. So now let's consider that in light of that, since the hypotenuse in the last one was the square root of 2, the two legs are 6, so this one is going to be 6 times the square root of 2. Simply put. All right, hope that was helpful. And there you go. So what makes them special, actually? Well, what makes them special is there's a couple things. They're easy to work with because they're going to show up a lot in proofs and also in trigonometry. This is a 45-degree angle, and a 30-degree angle, and a 60-degree angle, and a 90-degree angle. So we got these relationships of very common sort of basic angles that we're going to deal with. And we can use them as special cases that will help us work out more complex problems. So your answers will vary. So I'm going to leave that at that. And there you go.